All right, we're going to try one more acid-base titration example. This one where we have to calculate a volume of one of the participants instead of a concentration. So let's say we have 20.00 milliliters of 0.125 molar H2SO4. And that's titrated with 0.120 molar NaOH. What volume of titrant? We know it's the titrant because it's what's being added. It's titrated with NaOH. What volume of titrant is required? All right, so we're going to solve this one in the same fashion we did the other ones. We write out the equation and then do the calculating. So now we have H2SO4 plus NaOH makes water and a salt. And the salt this time is Na2SO4. All Bronsted-Lowry acid-base reactions are double displacement reactions. So we get the same kinds of products there. Now we have to balance it. We've got 2 protons to remove off the sulfuric acid, so we need 2 OHs. We get the same number of waters as we have OHs necessary. So we have a balanced equation. Now we're going to attack the problem. We start with the stuff we know the most about, which is the H2SO4. We're going to convert volume of H2SO4 to moles of H2SO4, and then to moles of NaOH, and then use the molarity to convert to a volume. So 20.00 milliliters of H2SO4. And for every 1,000 milliliters, it was 0.125 moles of H2SO4. And then we use the stoichiometry to convert to moles of NaOH. So for every 1 mole of H2SO4, in the denominator here, there's 2 moles of NaOH from our equation. Now this time we're converting to a volume of titrant. So the next step is an additional conversion factor. We're going to use the molarity, remember it's moles per liter, 0.120 moles per liter of NaOH as our next conversion factor. We want moles of NaOH in the denominator. So it's 0.120 moles of NaOH for every liter. Remember that's 1,000 milliliters. And if we look at our problem, the milliliters of H2SO4 cancel, the moles of H2SO4 cancel, the moles of NaOH cancel. We're left with just the volume of NaOH. So then we calculate again. 20 times 0.125 divided by 1,000 times 2 times 1,000 divided by 0.120. $41.67. And again, you can't solve this problem just using M1V1 equals M2V2 either because of the mole-to-mole conversion. All right, if you solve one as a monoprotic, this is going to be a 1-to-1. If it's triprotic, it's 3-to-1. If you're solving it for the concentration of the acid, some things are going to get turned upside down. But you have to just take them on a case-by-case basis, calculate moles of what you know, moles of what you're looking for, and then volume of what you're looking for. Okay? Good luck, folks.